Hello YouTube and welcome to this channel. In this video I'm going to continue the two previous videos regarding the inductors, basically excitations in the transient simulations, and I'm going to show you the results of what we got from our simulation results. One thing I want to show you first is how well the meshing looks like. I'm going to I basically moved my design into the YZ axis, and I'm going to select the global YZ under the planes, and then I'm going to go to the Maxwell 3D. And then under the fields, I will go select plot mesh, and that will be mesh for everything. And so right now the mesh is not showing because it's on -1, the time step. Sorry, should have not moving the mouse. So let's just once again bring the system into the best view that we can watch. Okay, and over here. And now we can double click on this and go with 0 second. Sure. So this is the mesh that we have, and currently this is I wouldn't basically call it a good resolution for the mesh, but I guess for the simulation results that we have, that's how does it look like. We can perhaps have like a better result if we go with higher, finer mesh. But anyway, so this is the mesh, and if you want to see some fields, for example, I'm going to get rid of the plot of the mesh, and I can again go select the view and go under the fields and select, for example, the HB or whatever. I'm going to go with the magnitude of the B over the all objects, and that's a graph that well, because the magnitude here is incredibly high inside this, we see everything else as a blue line. Of course, this is at 0, by the way, so we can change that to different like fields, and you can see that the fields that we keep growing. I probably can do an animation here, and you can see how does the animation works here. While the animation is running, I think I will pause the video, and when the animation is getting ready, I will show you the animated results. Okay, the simulation, basically the creation of the animation is over, and you can see over here that we have a pulse on top of a sine wave. Clearly you can see how the fields are showing here, and one thing that I changed here is I double click on this field and I made it to be logarithmic. I'm sure that you guys know how to do that based on the previous tutorials that I showed you. So this is perfect, and it shows how beautiful this graphs look like. I'm going to close that. I'm going to go right click on the results and show you some other interesting things. One thing that I want to show you is the current of the inductor, and I'm just selecting the current here, and you can see that the current has a pulse, basically a sine wave, with a 1 kilohertz rectangular a PWL that we added on top of the 50 hertz sine wave. It's pretty obvious that you can see that, and you can see that the current is going from 1.5 amp to 4 amp, and this is our inductor. And if you add for example the induced voltage as well, you should be able to see actually, I'm sorry, you have to go and check out the input voltage. So find this one. And you basically see that what we applied is this, pretty much a sine wave with a wave on top of that. Very, very useful tool, and please use this later on. It will save a lot in your designs. One other last thing I'm going to show you is the inductance of the median, just in case you are curious about that. In the transient simulations, you get the inductance over the time, and you can see it's pretty constant, which makes sense. We are not expecting to see a variable inductance, and the value here is it's in microhenry, and it's like 400 microhenry. This is the inductance that we get here. Okay, and I guess that will conclude our tutorial here. If you guys have any questions, please do not hesitate to ask in the comment sections. If you guys know the answer of some comments, please do help and share your answers with your other people, and this way the questions will be answered faster, and some of the questions I don't know the answers, you guys can come in and help. And also, if you have a design that you do want to, you do need some consultants with that, you can email me at the email that is shown here, and we can follow up from that point. Thanks for watching.